So liquid handling robots have become a bit of a biotechnology staple that allows scientists to perform laborious or repetitive protocols and execute them in high throughput. However, present software is often designed to automate traditional hand pipetting protocols and often struggles to harness the full capabilities of laboratory robots. So in the SFELT lab, we developed Pyhamilton, which is an open source Python-based package, which allows scientists to double the speed of automated lab assays if they want, and it can be used to execute things like complex pipetting patterns by simply inputting a matrix or flow-through rates or volumes. But we can also use Pyhamilton to create methods that allow the robot to change its program in response to real-time data that's being generated. And just one of this is that we can actually control the density of hundreds of bacteria cultures over many days without user intervention, simply by allowing the robot to learn the growth rate of each individual bacteria. And what we hope is that by using Pyhamilton, we'll be able to enable scientists to sort of dust off those liquid handling robots that may be collecting dust because they were acquired for one very specific type of experiment, and start to think about how they might use them to not just replace a scientist holding a multi-channel pipette, but really perform experiments that no number of researchers could perform, no matter how many you had lined up side by side. We also want to debunk this sort of academic idea that high throughput robots really replace technicians, because with Pyhamilton, you can perform entirely new types of data responsive experiments and then share them in an open source way with the community. And you can do this all while simultaneously taking advantage of the increased accuracy, reproducibility, and throughputs that are allowed by liquid handling robots.